This is Learning Assessment Problem 8.7. This deals again with the use of phasor analysis in sinusoidal circuits. We are told that the current in a 150 microfarad capacitor is of the phasor form 3.6 at an angle of minus 145 degrees amperes. We're given information about the frequency is 60 hertz, and we are to determine the voltage across the capacitor, presumably in the time domain. So we'll calculate the radian frequency is equal to 2 pi times 60 hertz, and that is equal to 377 radians per second. And we have the phasor the capacitor voltage current relationship can be expressed here. We have a capacitor, we have a phasor voltage across that capacitor. Ultimately, we want to find the time domain voltage across the capacitor, and we have the phasor current I sub c and the corresponding time domain current IC of t. The relationship in the phasor frequency domain is that I sub c is equal to j omega c times the phasor v sub c. We can solve this for the phasor v sub c is equal to phasor current I sub c divided by j omega c, or v sub c is equal to I sub c divided by omega c at an angle of 90 degrees. So in our case, we have V sub c is equal to, the current is 3.6 at an angle minus 145 degrees amperes. And then we're going to divide by this sinusoidal admittance of the capacitor, which is 377 radians per second times 150 microfarads at an angle of 90 degrees. When we're doing these division problems, we'd like to have the complex numbers expressed in their polar formats. This is equal to 63.66 at an angle of minus 235 degrees. This is equal to 63.66 at a phase angle of minus 235 degrees. And the units